In this video, I will talk about finding the speed of a bullet by using a spring and a wooden block. So we have a mass that is connected to a spring, and here we have a gun and a bullet is fired from the gun. And we know the mass of the bullet, we know the spring constant, and we now need to find out what is the speed of the bullet. The mass of the bullet is 10 gram, and the mass of this block, which is M, is 5 kilogram. When the bullet hits the block, then the block and the bullet both moves together. And as it is connected to a spring, there is a compression in the spring. And the compression in the spring is 10 centimeter. That means the spring is now compressed by 10 centimeters. So this is what it is given. And the spring constant, which is the characteristic of a spring, is 200 Newton per meter. That's the spring constant. So let's divide this problem into two separate parts. When the bullet hits the block, the bullet is now embedded into the block. This is a perfect inelastic collision. Perfect inelastic collision. That means only the momentum is conserved, not the kinetic energy. And the both bullet and the block move together with a common velocity, that is v. And when the block and the bullet compresses the spring, then all the kinetic energy of the block and the bullet is now changed into the elastic potential energy, because it compresses the spring. So all the kinetic energy of the block and the bullet is now changing into the elastic potential energy. So let's start from here, the energy conservation problem, and then we'll go backwards. So here, what you see here, the kinetic energy of the block and the bullet, this kinetic energy of block and bullet is now equal to the elastic potential energy of the spring, or the spring mass system. Okay, so what is the kinetic energy? The formula for kinetic energy is half mv squared, and here the mass will be the mass of the block and the bullet together. So this is the half, and the mass of the block and bullet together, and v is the velocity and the square. And the elastic potential energy is given by half kx squared. K is the spring constant, and x is the compression in the spring. So this is the elastic potential energy, half kx squared. The half cancels out, so we can solve for the v, and the v is now x. So if you solve for the v and a square here, then you will have k over m plus m in the square root. We know now all the variables here. X is given, and the compression in the spring is given 10 centimeter, and it does say here the 10 centimeter, that's given. So we change the 10 centimeter to meter, which is 0.1 meter. The k value, the spring constant, is again given, which is 2000 Newton per meter. The mass of the block is also given, 5 kilogram, and then the mass of the bullet, which is 10 gram, and we need to change that into the kilogram, which will be 0.1 kilogram. So if we solve, then we get the velocity of the block and bullet together. Remember, this is not the velocity of the bullet. This is the velocity or the speed of the block and bullet together. So we now figured it out, the common velocity, Now take a look into this problem now. So this is a complete inelastic collision problem. So we now go back and solve the this collision problem now. So we know now in any collision the total momentum is always conserved. It always remains conserved. So that means the total momentum before collision has to be equal to the total momentum after collision. So we now need to equate the total momentum before collision and after collision. So here it is. So we are applying the conservation of momentum. So momentum before collision and momentum after collision. So what is the momentum? The momentum is the mass times the velocity. So now just take a look here. What is the momentum of the bullet? The momentum of the bullet will be m times v. What is the momentum of this block here? Is 0, because the block is sitting stationary. The block is at rest, so it does not have any momentum. The only momentum is coming from the bullet. So the before collision we have only this momentum mv. Now just take a look at the momentum after collision. After collision, the block and the bullet together moves with a certain velocity, which is v. Both have exactly the same velocity because the bullet is now embedded into the block. So the momentum is now m plus m, that the total mass, times v. M plus m times v. Remember, the momentum is equal to mass times velocity. So you need to take the mass, corresponding mass, and the corresponding velocity. So this is the mass of the block and bullet together, and this is the velocity of the block and bullet together. And we are going to solve for the velocity of the bullet. So just dividing both sides by m. We know the mass of the block, which is 5. The mass of the bullet is 0.01. And the velocity we just found it out is 2 meters per second. So if we solve it, we get 1002 meters per second. So this is the speed of the bullet. So this is a fairly simple experiment where we can find out the velocity of the bullet just by using a spring and a wooden block. And again, as I mentioned, this has two separate problems. The one is energy conservation and the other is the collision problem. So again, if you have any questions, any concern, any comments, any feedback, please write down in the comment section below. And do not forget to like, share, and subscribe the channel.